The semiconductor has transformed every industry it's touched. Our movies, music, telephones, and newspapers have all created a direct connection to the binary language of computers. That direct connection has inevitably lowered prices, increased quality, availability, and convenience. Ion Torrent has developed a new sequencing technology that brings the transformative power of the semiconductor to the life sciences. Ion Torrent's true semiconductor sequencing enables a direct connection between chemical and digital data, making sequencing fast, simple, and massively scalable. Up to now, we've had to go through an intermediary, such as light, to translate chemical data into digital data. That requires optics like cameras, lasers, and scanners. As a result, sequencing is complex, slow, and hugely expensive, making the technology available to only the biggest research labs. In a way, the evolution of sequencing has been a lot like the evolution of the computer. ENIAC, the first modern computer, was 80 feet long and painstakingly slow by today's standards. Lab gels was a tedious and cumbersome process. Using fluorescence improved safety and throughput, but it was still a major undertaking just to sequence a gene. Mainframe computers were faster than ENIAC, but still so expensive that only a few organizations in the world could afford to buy and run them. Likewise, capillary sequencers had higher throughput, enabling the Human Genome Project, but few labs had the resources to support them. In the 1970s, the mini-computer put computing technology within reach for hundreds of organizations. Next-generation sequencing, led by 454 Life Sciences, likewise enabled many more labs to purchase their own sequencers, though it took up to a week to get results and they cost up to $500,000, pricing tens of thousands of labs out of the market.
We shall prevail.
Like 1984.
The desktop computer killed mainframes and mini-computers by making computing fast, affordable, and accessible to everyone. By using semiconductor technology, Ion Torrent has done the same thing for sequencing, putting it within reach of tens of thousands of labs that could never afford big, expensive, light-based systems.
Noyce's monolithic idea, as captured in Moore's law, made computing ubiquitous. My goal is to do the same thing in life sciences, bringing Moore's law to DNA sequencing to make DNA sequencing ubiquitous in both research and the clinic, creating that portal between the chemical and digital world.